Our Sun is a medium-sized star with a radius of about 435,000 miles, 700,000 kilometers. Many stars are much larger, but the Sun is far more massive than our home planet. It would take more than 330,000 Earths to match the mass of the Sun, and it would take 1.3 million Earths to fill the Sun's volume. The Sun is about 93 million miles, 150 million kilometers from Earth. Its nearest stellar neighbor is the Alpha Centauri triple star system. Red dwarf star Proxima Centauri is 4.24 light-years away, and Alpha Centauri A and B, two Sun-like stars orbiting each other, are 4.37 light-years away. A light-year is the distance light travels in 1 year, which equals about 6 trillion miles, 9.5 trillion kilometers. The Sun orbits the center of the Milky Way, bringing with it the planets, asteroids, comets, and other objects in our solar system. Our solar system is moving with an average velocity of 450,000 miles per hour, 720,000 kilometers per hour. But even at this speed, it takes about 230 million years for the Sun to make one complete trip around the Milky Way. The Sun rotates on its axis as it revolves around the galaxy. Its spin has a tilt of 7.25 degrees with respect to the plane of the planet's orbits. Since the Sun is not solid, different parts rotate at different rates. At the equator, the Sun spins around once about every 25 Earth days, but at its poles, the Sun rotates once on its axis every 36 Earth days. The Sun would have been surrounded by a disk of gas and dust early in its history when the solar system was first forming, about 4.6 billion years ago. Some of that dust is still around today, in several dust rings that circle the Sun. They trace the orbits of planets, whose gravity tugs dust into place around the Sun. The Sun formed about 4.6 billion years ago in a giant spinning cloud of gas and dust called the solar nebula. As the nebula collapsed under its own gravity, it spun faster and flattened into a disk. Most of the nebula's material was pulled toward the center to form our Sun, which accounts for 99.8% of our solar system's mass. Much of the remaining material formed the planets and other objects that now orbit the Sun. The rest of the leftover gas and dust was blown away by the young Sun's early solar wind. Like all stars, our Sun will eventually run out of energy. When it starts to die, the Sun will expand into a red giant star, becoming so large that it will engulf Mercury and Venus, and possibly Earth as well. Scientists predict the Sun is a little less than halfway through its lifetime and will last another 5 billion years or so before it becomes a white dwarf. The Sun has several regions. The interior regions include the core, the radiative zone, and the convection zone. Moving outward, the visible surface or photosphere is next, then the chromosphere, followed by the transition zone, and then the corona, the Sun's expansive outer atmosphere. Once material leaves the corona at supersonic speeds, it becomes the solar wind, which forms a huge magnetic bubble around the Sun, called the heliosphere. The heliosphere extends beyond the orbit of the planets in our solar system. Thus, Earth exists inside the Sun's atmosphere. Outside the heliosphere is interstellar space. The Sun doesn't have a solid surface like Earth and the other rocky planets and moons. The part of the Sun commonly called its surface is the photosphere. The word photosphere means light sphere, which is apt because this is the layer that emits the most visible light. It's what we see from Earth with our eyes. Hopefully it goes without saying. But never look directly at the Sun without protecting your eyes. The Sun generates magnetic fields that extend out into space to form the interplanetary magnetic field, the magnetic field that pervades our solar system. The field is carried through the solar system by the solar wind, a stream of electrically charged gas blowing outward from the Sun in all directions. The vast bubble of space dominated by the Sun's magnetic field is called the heliosphere. Since the Sun rotates, the magnetic field spins out into a large rotating spiral, known as the Parker spiral. This spiral has a shape something like the pattern of water from a rotating garden sprinkler.